Okay, now let's get started. You stop talking about your privacy secret because everything is on live. It's broadcasting. Yeah. Okay. Well, first I want to talk about the group. So if you still do not know how to find your group, you go to this web page, D2L page, the main page of this course. Okay. OO design, right? And then you navigate to this other. You click, then you in the drop down you will find the item called groups. Then you should be able to find your group information. Well, I should have a different view from you because I can see all the group, but you should only see your group, right? I don't know, but you should be able to find your group information. And every assignment from now on is set up as a group submission. Okay. I don't know how the group submission work in your view, but I only get one copy from each group every time. Okay. But I think is some settings there you need to coordinate with your group members. Okay. So if you only a few group, I add some member to a few group that they request for more members, or they didn't see that or something like that. But we do need to have some student that we need to assign to some group. So if you are in like online class, it's online group, or it's a group of face-to-face students mixed with online students, that's fine. Okay, so we want to mix a group with online and face-to-face sessions so that this inter-session group thing can help us like making communication, maybe using the tools that are available to us, including D2L, Skype, those things, email. Okay, so a lot of times a group is not in one location that's possible, right? So we communicate through all those modern communication tools, right? So we should have that in mind. We should have that ability. Okay, and midterm. I hope you enjoyed that. Well, yeah. Okay, the CRC card is gonna do on next Monday, but some group already submit that. I can give feedback soon, but I will give some priority to the midterm grading thing. So yeah, probably this week you can get some feedback on CRC and also this midterm. You can expect the midterm grade within this week. All right. Let's continue to talk about our design. Let's have some fun with the design. We were talking about use cases, requirements, right? How do we describe all these use cases? And we talked about the interaction diagram, sequence diagram. So all those notations. And now let's continue to talk about something about this requirements real quick in the week 7 thing, but it's only not a whole lot going on there. And we do have a template for describe your use cases, to describe the main sequence, the subsequence, the alternative sequence, and the arrow sequence. So yeah, you can use that template. And now let's talk a little bit about gathering requirements and requirement change and things. Then we jump to the week 8 is our first we'll talk about analysis of the system with the use case, how we use this, how we like improve the system with our use case. Okay, but now let's still talk about the requirements. Okay, so requirements are, you all know what are the requirements, right? From chapter 1 we talk about we want to have a system that meets the client's needs. If they want a list of guitars, we want to return a list of guitars. So here's some formal definition of that requirement. A requirement is a singular need detailing what a particular product or service should be or do. Right? That's just a definition. So that means a requirement is a single one described. And usually we have a sets of requirements that we need to meet for a system. And use case, we all know what that is. It's a sequence of stuff. So it describes all the scenario, how you interact with your system, okay, to achieve that specific goal. If you still remember, we have those main flows, subflows. You can document them, and you can also do that with interaction diagram, which give you a more direct visualize those use cases of that system. There's nothing to talk more about use cases. Pretty simple. And some tips here. Requirement. So good requirements ensure that your system works like your customer expected. Yeah, that means that's a good requirement. Sometimes it's hard to figure out what the customer's needs are. That's because of the miscommunication. Or if the customer can express them pretty well, sometimes it's just some party, they perceive that information in the wrong way. So that's possible. So that's also a limitation of using the natural language. So that's why we have something else to deal with requirements. It's called formal specification. A lot of you have taken that course already. But here we're not talking about that. But good requirements ensure the system works like the way it is supposed to work. Now make sure your requirements cover all the steps in the use cases for your system. Once you have the use cases, we have a whole bunch of use cases, scenarios. Under each scenarios, we have different sequence of use cases. Okay, so we generate all the requirements for the use cases from the use cases, right? If you remember, what are in the use cases? It's a description. So when we want to do this step, what functionality do we have? If we want to have a login, when we're trying to register a class, we have login function, login step. Okay, that means we need a login function for this system. And then we need a register system, a register for class. We need a register function, or after we log in, we should have some function to store the information, or we should have a database. Okay, all these functionalities, requirements can be generated from your use cases. That's why we want to document these use cases. And we want to visualize these use cases. So we can go through the use cases again and again to ensure that we have the correct set of the requirements generated from that use cases. Yeah. Okay, and what's even more, when you have the use cases, you can even find out what the customer forgot to tell you, because the customer are not experts in developing system. Maybe they do not know anything. They have only limited knowledge of how computer system works, right? It's possible, but they want a system to help them. So you cannot expect your client to tell you, okay, this is the set of the functionalities. But the clients, they can tell you the use cases, like what I want to do with this system. So you generate all these use cases documentation. From there, you know what the customer wants, and the customer may not know there's logging function there. They just want to register a class, but you generate that function, you think there should be a logging. Okay, maybe the customer do not know there should be a database there, but you can generate that kind of requirements from your use cases. And this case will reveal any incomplete or missing requirements that you might have to add to your system. Okay. So when we are trying to, for example, when we have a course project, making some sort of system, okay, you have all this list of requirements there already, which I give it to you, but there are some requirements. There are some requirements, the functionalities. Maybe what functionality I required is highly depend on those functionality which I didn't specify them in my documentation. Okay, but when you use those use cases of the system, you can easily identify those missing functionalities you want to add. Maybe some of the functionality do have dependencies on some other functionalities. That's possible. So that's the value of using these use cases. It's not just the documentation. It helps you to finish, to complete your, have a complete set of your requirements. Okay. So requirements change. That's something, yeah, something happens a lot. So it's constant in software analysis and design is change. So a complete path through a use case from the first step to the last is called a scenario. Okay, yeah. Right. So when you, how do you deal with the change? Is still, well, if you have some change to the system, it will be reflected in your use cases, right? Because how the user uses the system is changed, or the steps in the user system, sequences in the user system, in the user cases changed. For example, we'll see an example today how things change. Okay. It's not like the use case itself change. Like I need to register for class. This is the use case. It's not this case change. It's the sequences of the use case change. Okay. I need to register for the class. At first, I may have a sequence that without any logging. Right. So I just type in the URL, fill in my name, register for class. Okay. Then when you have this sequence, you talk with the client. The client said, okay, maybe it's not very secure to do this. Yes, register for class is my scenario. It's my intention to do this. But in this sequence, I feel that we need to have a logging step there. So that leads to a change in our use case. We add a step in the use case in the main sequence. Okay, in the main sequence. Therefore, okay, that leads to the change of the use case. Then, when you change something in the use case, you need to review that use case to make sure the change in the use case has been also reflected in the set of requirements you get from the use case. So use case also helps with the change of your requirements, right? And you need to plan for the change, for sure, because it's change all the time. Okay, because a software development process is a complex process which involved in developer team, they have different background, okay? And the client, they have different background. The stakeholders of this whole process, everyone has different background, has different assumptions. This change maybe it's because of a different background, different assumption. Also, situation changes. Like we have a system and then we find a pretty good subsystem. That's not the case. Okay, so then the client find out their competitor has a more fancy use case of the system, so they want to add that into your system, right? So that can change. So plan for that change. So that's the value of the use case. The use case help you to have a complete set of the requirements. Also, the use cases help you to deal with the change of the systems. Okay, so yeah, it's kind of explain why do we want to generate this use case documentation thing. And the interaction diagram, that's a pretty awesome tool to help you visualize everything. I think you get the information like quicker. You get more information from observing the diagram than no, it's not more information. Actually, you get the same amount of information, but if you're dealing with a diagram, yeah, it's more efficient. Okay, so that's something pretty simple. I just covered that a little bit. Okay, what we're going to focus on today, this week, is something about that UML and something about analysis to your system. Okay, now let me pour out this. So let's see, what is the analysis? So this step. So chapter 4, here chapter 4 means that textbook, chapter 4, something dealing with that. Okay, so we're now taking the software into the real world. So analysis, we're talking about analysis here. We define it as figuring out the potential problems and then solving those problems before you release your application into the real world to ensure your system works in a real world context. Okay, so there maybe, okay, there are use cases there. You generate all the requirements. You have a system that meets all the requirements. Okay, that's good. That's good. But okay, you should be clear that the clients, they also make mistakes. Right? They cannot have a very complete use case there. There's some problem they cannot expect. So so you need analysis to your system to ensure that it works in the real world context, because there are a lot of problems that you just cannot, it's not very easy to plan for. Okay, we will see an example. Yeah, so also we use this use cases to do the analysis. So analysis your use case lets you show customers, managers, and your boss, the developers, so how the system works in the real world context. It's important. Notice it's real world context. Okay, it's not just that we're thinking, but in a real world context. Let me show you an example here. This doggy door system. Okay, let me pour this out. To chapter 4, here we have example. So in this scenario, we're trying to develop a system, which if you hear the system hears a dog bark, it will open the door to let the dog out. Well, then somehow if the dog wants to go get in, bark again, and the door open, get into the room. So while this, if you have a dog at home, maybe this system is something of your interest, because you don't have to send a dog to the boarding service while you're traveling. Okay, so while this is kind of that system like that, but when we are trying to develop this system, yeah. So here, your software has a context. Right, so I need a bit bigger. So we've worked on writing a software. Haven't really thought much about the context. We should think about software like this. Okay, so before that, we have some sequence in chapter 3. I don't want to navigate back there. I just talk. Okay, so the sequence is like, okay, when the main flow is when the detector hears a bark, it opens a door, and then the dog goes out, do something, and then the dog barks again, and the door open. The dog go back in the home and shut the door. That's a main stream. That's the main flow. Okay, and the subflow there is when the system hears the bark. Okay, the subflow is the owner hears the bark. The owner press a button to let the dog out. So instead of the automatic door open. Okay, so the system allows the owner to have a button to open the door for the dog. Okay, all right. So that's the simple main flow and subflow of the system. But do you see any problem there when I describe this sequence? Here the bark, open the door, and the dog goes out. Here the bark again, open the door, the dog comes in. Any problem with that?
Soon the dog is going to come back and bark and then run off. Or there's not a dog outside the barks, and then just opens the door and lets whoever in and let the dog out.
Let the dog out? Well, it's like hear the dog and open the door. You can go out and in. That's fine.
Well, the bark could be from another dog.
Exactly. Yeah. So the bark could be from another dog. This is not described in the sequence at all, right? Yeah.
And how long is the door gonna stay open after hearing the bark?
How long?
So the door could open for a few seconds and shut, and the dog will still be in the house.
Yeah, that's it.
Or it might stay open.
And
way
bark
after
again?
The dog is outside.
And the dog can bark again. Yeah, that can be one of the potential problem. If it's like keep open for 24 hours, that doesn't make sense, right?
I think we already considered the door closing automatically. So
Yeah. So the first thing you mentioned is important. Bark. Every dog can bark. We have a lot of dogs in the neighborhood. So if we hear a bark and open the door, well, every dog can go into our house and screw things, right? So, yeah. So that's something in the real world context. So when you are just thinking about software system, you do not think about the neighborhood. Okay. But when we think about the neighborhood, okay, when we think about the real world context, we notice that, okay, in the neighborhood there are a lot of dogs. They bark, that's what causes the trouble. Yeah. And so, in the perfect world assumed by the system, okay, there's no multi-dog neighborhoods, but in the real world, every neighborhood has many dogs. and cats, and a lot of things. Okay, so we identify the problem, which is many dogs there, and every dogs can bark, right? So the remote thing is okay, but the bark recognize the dog, or as well as the other dog. So it's keep opening for other dogs. That's a problem we described here. Therefore, we have this set of the use case, modified use case. So the main path here, first is, can you see that clearly? Read it, read the text. Okay. So the owner's dog barks to be let out. The owner's dog. The bark recognized, here's the bark. If it's the owner's dog barking, if it is owner's dog barking, the bark recognized send the request to the door to open. The door open, the owner's dog goes outside, the owner's dog does his business, maybe a lot of business, important business. Okay, and the door shuts automatically. The door shuts automatically. The owner's dog barks to be let back inside. The bark recognizes, here's the bark. If it's owner's dog's barking, the bark recognizes, send a request to open the door. The door is open. The owner's dog go back inside. The door shuts automatically. Okay, so regardless of that timing thing, but here let's focus on this multi-dog issue. Okay, so this is a modified version of the dog thing. So we did some modification to the use cases here. All right. So that's when we put them in the real world context, we can identify the problem. Here is the real world context is the neighborhood, okay, and a lot of other things like, for example, the registration system. Sometimes if you put that in the real world, well, it's possible that one of the potential problem is because student, you open the registration at a certain amount of time, so student or they are going to deal with the registration system simultaneously, almost concurrently. Okay, so that brings a lot of trouble. First, okay, so if I am in the middle of selecting that course, maybe 100 students is selecting one course simultaneously. How do you distribute that? Which one should get that? Like, right? Or somehow if you lock the position, sometime if it's an airline system, right? You're in the middle of the payment, but somebody else has already paid for that, or they're doing quicker job to do that. So how do you deal with that scenario? Right? That's, or something like real world. If you put system in real world context, you should be able to identify those problems. Okay. But this analysis helps you to identify the problem that is missing when you are maybe just talking about the scenarios, those use cases. Let's take it one step forward, put it in the real world context. Yeah. So what we identified from the system is we need to recognize the bark as the bark from our dog, the owner's dog. Okay. So it shows that we need to change the use case, to modify the requirements, to add a new use case for storing a dog bark, right? We need to aid the comparison of barks into the recognizer. Okay, now let's see how we do that. So far what we have is this use case, like evolved with new requirements for the dog barking recognizer, which should identify exactly that's the owner's dog. Okay. I want to show the whole page, but okay. So when we design for that, that means if we have a system already, that means if we change the requirements, the next step is we're going to change in the, what's the next step of the requirements? Let's think about the software lifecycle requirements. Next thing is design. Yes. When we have requirements change, next thing needs to be changed is the design. Okay. Suppose we have the system built design already. Okay, sparking, letting out, the things designed already. Now we're trying to use the recognizer to identify if that's the owner's dog. Okay, so we need to change the design, and in order to change the design in the object-oriented design, we need to make sure that our change to the design fits in the principles of the object-oriented design. We want to have a loosely coupled classes there, and we want to have every class to do its own business. Remember? Yeah. So here we use a delegation in the dog store to help us to aid in this design, to aid something to the original design. Okay, let's see how we do this. First, the bark recognizer get a bark to evaluate, right? So this hardware hears the barking, wraps a sound and the dog's bark in a new bark object, and delivers the bark instant to the recognize method. It's pretty straightforward. We get that bark and we use a recognizer to identify if that's a bark of that particular dog. And what the bark recognizer do is it gets the owner's dog bark from the door to detect the bark. The recognizer method called get all allow the bark on the dog's door is attached to and retrieve a bark object representing the dog's owner's dog's bark. Yeah, and it do the comparison here. Okay, so question here, alright, is we have this bark we hear from some dog. Maybe it's in the neighborhood, it's in the home. And we have a bark that's stored in our system. Okay. So question here is, when we are trying to, there should be a comparison, right? But here we have different classes here. One is bark recognizer. One is dog door. One is the a bark. 3 classes here. If we're really trying to do the comparison, okay, where should we have that compare method? In which class do you think we should have the compare method? 3 of them here. Who agree with putting that into recognizer? You just okay, recognizer, you too, yeah. And how about the dog door? Okay, how about the bark? Then where do you want to put that?
In all 3.
Yeah, let's
I'm leaning towards the recognizer.
recognizer.
Yeah.
Yeah, that makes sense, right? Because the recognizer, it recognizes the thing. It recognizes the thing. But here the recognizer is like, okay, I hear what the sound. I hear people talking. It's not, I hear the bark. Okay, that's a bark. Let's recognize the bark. But it doesn't say that recognizer should recognize the particular dog's bark. Yeah, that may make sense, but here, let's think back a little bit to the chapter 1 we talked, the guitar. When we're trying to compare the guitar, where do we do that?
Guitar spec?
Either
Guitar spec?
spec
Yeah.
class, yeah.
Okay, we were doing that in the inventory class, right? And then later on we find it's better to do that in the guitar specification class, right?
Yeah.
Here, then how about
So-
here?
So you want to create a new object and have the bark recognizer talk to it?
Yeah, there's something like that, but here you don't have to create a new object. You can just use this bark,
Use that one, okay.
right? You can do the comparison in bark,
Yeah.
right? Because bark, this class, it has all the information of a barking, right? It has maybe the frequency of the bark, the volume of the bark. So a bark has a lot of features.
Okay, so you don't have to bring all that information down.
Yeah, if you're doing the comparison within this bark, you don't have to so everything is communicated internally in the bark. Okay.
But here the bark is just a single object, right? A class.
Bark
Like,
is
so, yeah,
is a
if
class.
we do the recognizing part or search in the bark, it's like it has to get other barks and compare it with it, isn't it?
It's just need a bark to compare with another bark.
Yeah.
Okay, so if you're using Java string, every Java class has dot equals. Remember that?
Mm-hmm.
Okay, so you can compare everything, every object with another object if they are equal. Okay, so here what I suggest is putting that, maybe you want to call it equal or comparison, those kind of method inside this bark, so that you don't have to say like door dot door, bark dot, if bark dot frequency equals bark store dot frequency, and blah 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 blah. You have to communicate a lot. You have to call a lot of information from the bark, but you can finish everything within that bark to keep the every class as loose scaffolding.
So what is the relationship between the bark and the bark recognizer?
Bark recognizer recognize the dog bark. It detects, okay, a dog barked, and then it created a bark object.
I thought the direction was going from the door towards the bark recognizer.
Let me see.
That's what I thought. I thought the door gets the bark, creates the bark object, and sends that to the bark recognizer, and then the bark recognizer sends some information back to the door, whether it is equal or not equal.
Okay, so yeah, forget about those arrows for now.
Okay.
Because we have a lot of changes afterward.
Okay.
Okay, so maybe that's the original design of the system, but now we have 3 of them. As a dog door, recognizer, bark. Okay. Yeah. Okay, let me check back real quick. Okay, it's this way. Yeah. The door actually door actually, yeah, the origin system is the door. It hears the bark, right? It hears the bark and deliver the bark instance to the recognizer method. Yeah, recognizer method. Yes, you're right. So this thing hears the bark and it creates a bark object, send it to the recognizer. Okay, if that's a bark, then it then goes to the bark to open the door, to the dock door to open the door. Okay, but now the recognizer is going to call the bark dot compare or dot bark dot equals, but the implementation of that comparison is within this bark. Okay, is within this bark. It's the same as the principles what we were learning in the chapter 1. Remember that. So the inventory is going to call the comparison between the guitar specification. But the actual comparison, the actual algorithm of comparison is within that guitar specification. Here the actual code or algorithm of comparison is within this bark. That makes it a good design, which makes it fits more like OO design principle. Yeah. So we put some sort of bark thing, a comparison in the bark. Yeah, here. Bark recognizer delegates bark comparison to bark. Yes, it's called delegates, right? Recognize is it does the job, yes, but it does the job in a fashion that it delegates the comparison to the bark. Okay, like I am for another example. Okay, so when you go to KSU, okay, to learn, have some project, to learn to have the diploma, you want the KSU is responsible for your education, right? So suppose there's a class called KSU. KSU is going to take care of your learning and then award you the diploma, right? But who actually does that job is another object, right? Here, me and other faculties in the KSU, okay? So like KSU class will delegate it's actual like teaching or service those functionalities to me and to other faculties and staff in KSU. So that's this kind of logic. Okay. So here in the object oriented, we are really trying to simulate the way how it works in the real life. Okay. So that it fits more of a logic, it's easier to understand and change. Alright, a lot of benefits of doing that. Also, you can, well, if you are actually implement this software, it's possible that you do a lot of things. Software can do a lot of things that doesn't exist in the real world. Like this KSU example, you may just want to implement everything in a single class. The whole system have only a single class, which is the worst design, but it may work, yeah, somehow. But that's a worst design. So you have a KSU to do all the job, teaching KSU class to teaching, to do research, to do service, okay. But that's in real world, it doesn't work that way. KSU just delegate those jobs to everything else. Or it's a safety. Okay, KSU is gonna guarantee your safety, student safety. But that job is delegated to maybe public safety or police department. So that's called delegates. Okay, hope you can understand this delegates thing. So here it's the same. Although the bark recognizer is going to be responsible for recognize the owner's bark, the owner's dog's bark. Owner's bark. Okay, recognizer is going to be responsible for that, but the actual job is delegated to the bark to like have the comparison. Okay, this makes sense because bark knows more information about bark, but recognizer doesn't. Okay, like I want you to compare your. I want you to have a self-evaluation of your learning. So that means that you may have a more insights to give a evaluation. That means because when we're doing evaluation, we always have a like self-evaluation and peer evaluation and evaluation from your supervisor. Okay, they are from different perspective, but your self-evaluation, you have more information about yourself, and so that you can have a different kind of evaluation. Yeah, and bark knows more about bark, so we let bark do the comparison. Yeah. Okay, let's see. The recognizer method asks the owner's dog's bark object to see if it's equal to the bark instance supplied by the hardware using bark.equals here. Right, remember string.equals. Well, Java has all these functions there. Okay. And then first step here, bark decides if it's equal to the bark from the hardware. The bark object representing the owner's dog's bark figures out if it's equal. And well, here we have some other needs. Oh, it's not here, sorry. Yeah, so this explains what I just said. Bark knows more about bark, and the details of how this comparison happens are hidden from all the other objects in the dog door application. Again, that's the principle of the object-oriented design, right? So encapsulation. How you do the comparison, I don't care, but I don't care, and it's not like I don't care. It's I shouldn't care, because if I care about how you implement these details, it's not gonna do good to the future change to the system. Because if I know the detail, I'm using the detail. That means if that detail changes, I need to go back to everything that uses details to change that thing. Okay, that will lead to a lot of maybe errors, mistakes there. Yeah. So that's the principle. Put thing in the bark. Put comparison in bark. Put comparison in guitar specification. Okay. Yeah. So that's something like the power. Yeah, the power of loosely coupled applications. What we were trying to do is we want to make things loosely coupled. When we add a new functionalities, requirements, when we're trying to design for the new requirements, we add some functionalities. Then we trying to keep the design loose coupled. Okay. So the delegation is a good way to help you improve the loosely coupled applications, to reach loosely coupled. Yeah. So, right, this is here. Yeah, this is probably the code within that recognizer. The recognize function will call the equal function. We'll call the equal function from the bark, so that yeah, it knows, it have the comparison. So if that equals, then door open, right? So good thing is, yeah, example of that change is, now let's assume that we have a different kind of bark. One of them is maybe MP3, WMV, MP3 format, and some of them may be of the other format. But all those details, does the recognizer need to know them? No. If we want a future support for MP3, maybe MP4, maybe some other format, okay, we just need to do something in the bark, change something in the bark. But recognizer, we can just leave it there. We can change without even touching the recognizer. So that's the amazing thing about delegation, loosely coupled. Yeah, suppose we started storing the sound of a dog barking as a WAV file. We need to change the equals method in the bark, but leave the recognizer alone. Yeah, so that's the principle here. Any questions so far? Any questions so far? You understand everything, right? It's pretty simple, straightforward. We just want to follow this principle, and you should understand why we follow the principles. So, yeah, it's make it hard to follow the principle if you do not understand why. So all I'm explaining here is why, and you sort of have the idea why. Keep that in mind. Yeah. All right, let's go back here. So use delegation. We use delegation to change the design. Delegation helps our apps to stay loosely covered by making our object independent. So changes to one object don't require change to another object. And sometimes you, if you add another functionality, if you change the function, change the use cases, which result in some other change of the functionality, maybe not change. Maybe you have a new functionality to your application. So think about the delegation first. Okay, especially it's a new functionality. Okay, you need to identify which class is ideal to include this functionality. If you cannot find, if you think, okay, maybe you have a new functionality called feed the dog, where it fit into any of the classes. Recognizer, can recognizer feed the dog? In real world, no. But in the software development, unfortunately, we may just for convenience we put a feed function there, right? But in real world, no. Recognizer doesn't do that. The door doesn't feed a dog, right? If you want your door to feed a dog, you need to attach some other hardware there, which helps you to feed the door, feed the dog. So here also it's also true in the software. Okay, so if we want to add a function like feed the dog, definitely we need a new class, like a dog feeder, something like that, a new class to do that. All right. Of course, we have a dog feeder hardware there, but somehow, if you just want to quick development of your system, implementation of your system, you may like put that feed dog function in the recognizer, which calls the which communicate with the dog feeder hardware to feed the dog. So that will bring problem. That will work, but it bring problem. It doesn't fit in the object-oriented design principle, and it will have a hard time to change maintenance. Yeah. Okay, another problem here is when we're doing the real world analysis, we find multiple dogs, yes, and we modify the problem by adding a functionality of the recognizer to compare them if they're equal, and the equal is implemented in the bark. That's what we just did. Okay, and then we do some more analysis. We find that we identify another problem is in the real world, dogs have more than one bark. Right? If you have raised a dog, who have a dog at home? Who keep a dog at home? Good. Yeah, they have different barking. So, and that means different things. Sometimes it's I want to play. Sometimes it's they just want us to pat them out of water, go outside, or to go outside now. Pretty urgent. Yeah. Right. So, well, I have dogs at home, so I know this thing. It's different. So that's a real world scenario analysis. So that system doesn't fit in this analysis, right? Because there are a lot of them, a lot of barkings. We cannot just pour a barking, start barking and comparison. Maybe they bark something else. So that leads to some other changes in our use cases. Yeah. So solution must include that a dog has multiple barks. So the dog door should store multiple bark objects. Right? Yeah. So right, so that leads to some other changes. Let me see if we are going to talk about these changes here. So you can think about that first while I'm looking for that part. If we want to compare with multiple dog barks, what change should we make? First, it's here, yeah. The dog door should store a whole bunch of them. Yes, exactly. But now we cannot just use equals, right? Because we're compared with a lot of them. We cannot just compare a bark with an array of bark using equals.
If you're able to search for it, specific bark, I want to see if it's in there.
It should be a separate class.
What's that?
It has to be a separate class, right?
Separate class?
Or a different.
Well, yeah, we can do that in a separate class, but let's see first. Let's see if we can solve the problem within the current classes without adding new classes. Let's see if we can do that. Think about that. So in my mind here, we are using equals, right? But it's comparing 1 to 1. Probably we need to have another method called comparison, which may call this equal and compare this bark with a group of barks.
Why do we need multiple comparison?
Oh, because we are storing 20 of the barkings right now. Dogs has different barks.
So when we are comparing a bark against
A set of bark.
a set of barks.
Yeah,
So
to see-
identify the one that matches.
To see if that is one of them. To see the bark we just hear is one of them. It's one of bark that's pre-stored there. Right. Okay, here. Can we just do that? Just in this bark, instead of equal, we have a compare method. compare.
It looks like we have to go through a loop.
Yeah. So if we have the comparison method, it has to have a loop to call this equals
Yeah, so we have to.
like 20 times.
Each bar-
Yeah.
bar- That bar against each of those bars in the list.
Yeah. But where does the loop go? Which class do you think?
It should go in the bar, because isn't that why we have the,
Yeah. Right, because we're going to call that equal, right? And we need a lot of them. We need information from the bark, right? So let's assume that for now. Let's assume we put something in the bark. All right. And now we change something to the use case first, because we have something new, right? We need a group of them. So the owner stock barks to be let out. The bark recognized. Here's the bark. If it's the owner stock barking, the bark recognized sends a request to the door to open. Okay. Let me find that part. Yeah, the part is not here. It's here. Sorry. Alright, which page is this? I'm trying to see the page number. 167. Okay, that's about the design. Okay, now it doesn't talk about that issue, but here, let me talk about it. So here, when we're trying to compare multiple of them, instead of modify this equal, I think we need we need to delegate that comparison also to the bark, to compare that with a group of the barking. But it's gonna call the equal method in the loop, like what you just mentioned. Like how many stores there, we have a loop there to go through all of them to see if that's a single one of them. Okay, so that's about that delegation. Yeah, I thought about that question, but I So that's something I read from the book, but it's actually come out of my mind. All right. Let's finish the part. Everything. Okay. Then okay, the rest thing is we're talking about the design from the use case, how we generate all these class diagrams and these functions, what we should have from use case, how we generate this design from the use case. So simply speaking, you should use the nouns as your use case, in your use case, as the classes, and use all those verbs. Maybe the verbs, usually use the verbs as the functions of the class. It's not always true, okay? But just a simple principle here. The nouns as the class, verbs as the method of the class. But maybe not all the nouns. Some of the nouns may not need to be in a separate class, okay? Like the dog. We don't have a class called dog in that design, right? Because dog is something that is living. We do not model a living stuff in the system unless that living stuff needs to interact. But in this system, it's actually dog barks, but dogs is not really trying to interact with the system. It won't have a it participant in this process, but it's not like a system is detecting the dog barking, but it's not like dog actively doing that, and it doesn't participate in the interaction. So we won't have the dog as a class there, but in the system, in the maybe school registration system, you will have like manager class, maybe user class or student class. Okay, that case students is living things, but we model students there because the students need to have some interaction with the system. So the system presents some information, students select this course, and the course needs to be stored. That's called interaction. But the dog doesn't. Okay, so we do not need to model the dog. But everything else, if you see it's a noun, probably it's highly possible that that's a class. If you see a verb, it's highly possible that's some of the function in the class. Okay, let's see here. So if we say verbs, usually the methods, the nouns in your case, in the use case. It's called to figure out this nouns and verbs. This process we call it texture analysis. Okay, it's also available here in this textbook. See, we are circling all these things. Here are all the nouns we circled. The dog, the bark recognizer, dog door, remote control, request, owner, something like that. But not all of them are modeled as a class, right? Only the recognizer, the bark, and the door, they are modeled as a class finally in the system, but they all come from the noun of your use cases, right? And how can we decide? Yeah, like I said, we don't model the dog. And the user, do you see a user class in the design? Do you see there's a need for the class of user? No. Although the user is just pressing that button. Flat, no, right? So why don't we model the dog and the users? That's yeah, simple principle. We do not model the living things unless it has some interaction there, and we will talk more about that in the next class. All right? Yeah. Time is up for today. Okay. Thank you.